this blue triangle is an isosceles right triangle. That is considered a special right triangle. There's only two right triangles that are special, and this is one of them. The name that's given to it isn't just isosceles right. It's called actually a 45, 45, 90 triangle. That's because the measurements in the angles are 45 degrees, and 90 degrees. We know it's isosceles, so those angles are equal. So a 45, 45, 90 triangle is what we're working with here. This blue triangle on the left is similar to the one on the right. They both are 45, 45, 90 triangles. And we're going to start by looking at a couple of examples and then use a little bit of inductive reasoning to figure out the pattern that's going on. So let's say that the length of this side is equal to 3. Because it's an isosceles triangle, that means that the other leg is equal to 3 as well. And I don't know the length of the hypotenuse yet. However, I do know that it's a right triangle, so that means the Pythagorean theorem can be used. I'm going to use a temporary variable and say for right now that that length is x. And then using the Pythagorean theorem, we could say 3 squared plus 3 squared is equal to x squared. 3 squared is 9, 3 squared is 9. So when you add those together, x squared is equal to 18. Now our goal in this was not to solve for x squared, it was to solve for x. So then we'd have to take the square root of 18 and use the algebra skills of breaking down radicals. So you're going to write x equals square root of 18 and then branch down from that, trying to figure out what perfect square will go into 18. I know that 9 goes into it. 9 times 2 is 18. The square root of 9 is 3. So I can cross that off. Root 2. So x equals 3 root 2. In that 45, 45, 90 triangle, I was only given one leg of 3. The other leg had to be congruent to it, and then the hypotenuse turned out to be 3 root 2. So there's our first example of a 45, 45, 90 triangle. We're going to do one more and then look for the similarity between them as far as how can we know what the different lengths are going to be. So I've got another right triangle. This one looks a little bit bigger. We're going to say that this length is equal to 5. And our goal then is to find the length of the other two sides then in this 45, 45, 90 triangle. I'm given that these two legs are congruent. That's one way I know it's an isosceles right, or 45, 45, 90. Sometimes you might be told that one of the angles is 45 degrees, or maybe you're told that both of those angles are congruent. There's really a few different ways that you can determine that it's a 45, 45, 90. But this leg is 5, so the other leg must be 5. I'll say that the hypotenuse this time is y. Just use a different variable. And once again, my goal in this problem is to figure out what the length of y is. It's a right triangle, which means, once again, Pythagorean theorem can be applied. So I could say that 5 squared plus 5 squared is equal to y squared. 25 plus 25 is 50, so y squared equals 50. Take the square root of both sides. And like the last one, this one's going to break down again. Y is equal to the square root of 50. I don't want to leave it like that. I want to put it into the simplest radical form. So I'll break it down again. 25 times 2 is equal to 50. The square root of 25 is just a plain old 5. So y equals 5 root 2. What this leads us to then is that in any 45, 45, 90 triangle, the two legs will always be congruent to each other, and I'll just say that both of those lengths are x for right now. It could be anything. But if the legs are x, then the hypotenuse turns out to be root 2 times bigger than those, so the hypotenuse would be equal to x root 2. Key principle for us here is, if we're going from either of the legs to the hypotenuse, we're getting bigger, so we're multiplying by root 2. Whereas if we go from the hypotenuse to one of the legs, we're getting smaller, so we divide by root 2 to get to those legs. Now some examples with 45, 45, 90 triangles. We're trying to find the missing variables, or the value that we're missing. 45, 45, 90 triangle, one of the legs is 9, which means that the other leg, x, would be equal to 9 as well. Those two are going to have to be congruent because it's isosceles. And then from what we looked at before, to go from a leg to hypotenuse, we get bigger. to get bigger means we're going to multiply, and we're going to multiply that by root 2. So y equals 9 times the square root of 2. Next one, another 45, 45, 90. We have a leg of 2, which means that the other leg is also equal to 2, and the hypotenuse is root 2 times bigger than that, so y is 2 root 2. In the third problem, we have a leg of 16, which means that the other leg, x, is equal to 16, and the hypotenuse then would be 16 root 2. Jumping down to number 7, it's another 45, 45, 90 triangle. The hypotenuse is 10 root 2, so we're starting from a different spot in this one. The hypotenuse is 10 root 2, and we want to find the legs. To go from the hypotenuse to the legs, we're getting smaller, which means we're going to divide. There's a ratio of root 2 between the legs and hypotenuse, but in this case, since we're going smaller, we're going to divide by root 2. So if you took the 10 root 2 and divided it by our ratio of root 2, those would cancel out, which means that x equals 10. X is 10, the other leg of y is equal to 10 also. Number 8 is a similar kind of problem. Think about the questions that need to be asked in order to solve the problem. And my first question is, what kind of triangle is it? It's a 45, 45, 90. What does this 14 root 2 stand for? It stands for the hypotenuse. So we're going from hypotenuse to leg, which means we're getting smaller. And so the question is, do we multiply or divide? It's getting smaller, so we divide. Divide that by root 2, and you get x equals 14, y equals 14. And number 9, this hypotenuse is a square root of 2. So once again, we're going from hypotenuse to leg, so we're getting smaller. Divide by root 2. If you take root 2 and divide it by root 2, they would cancel out, which means that x equals really just 1, and y equals 1 as well. Number 10, hypotenuse is equal to 50 root 2. So to go from hypotenuse to leg, we get smaller. We divide by root 2. If you take 50 root 2 and divide it by root 2, you get an x value of 50 and a y value of 50. Number 11 is slightly different than any of the other ones we've seen. It is a 45, 45, 90. We have a leg of 7 root 2, and we're going to the hypotenuse. So from leg to hypotenuse, we got to get bigger. So it means we're multiplying. We're taking the value that's already in there, that 7 root 2, and we're multiplying it by our ratio number of root 2 to get to y. So we have 7 times 2, really. 7 times 2 is 14, so y equals 14. The other value we're asked for is x. X and the 7 root 2 are both legs. They're equal to each other, so x is equal to 7 root 2 as well. Those are our two answers for number 11. Always multiply by root 2 when you're going from leg to hypotenuse. Always divide by root 2 when you're going from hypotenuse to leg in a 45, 45, 90. Last one on this page is number 12. We have a hypotenuse of 5 root 2. So you need to figure out, in order to get to x or y, are we getting bigger or smaller? So then do we multiply or divide? And then what do we multiply or divide by? Well, I'm only going from hypotenuse to leg, so I'm getting smaller. I'm dividing by root 2. And if I divide that by root 2, the root 2's would cancel out. So y is 5 and x is 5 as well. Number 1, we have a 45, 45, 90. One of the legs is 5, so that means that the other leg, x, is equal to 5 as well. And then to go from leg to hypotenuse, we get bigger, so we multiply by root 2, so y is equal to 5 root 2. In problem number 3, we have a leg of 1, so the other leg of x is equal to 1 as well. The hypotenuse is root 2 times bigger, so if we multiply that by root 2, y equals 1 times the square root of 2, or just square root of 2 to simplify it down a little bit. Numbers 2 and 4 are a little more complicated, only because the algebra is more complicated. The process is the same. So number 2, we have a 45, 45, 90. The hypotenuse is 30, and we want to go to the legs. So like in all the other problems we've done with these 45, 45, 90s, when we go from hypotenuse to leg, we get smaller. We divide by root 2. So y would be equal to that, 30 over root 2. However, we can't leave that radical in the denominator. So going back to the algebra that we studied before, we're going to rationalize that, multiply numerator and denominator both by root 2. And what that does for us is it turns the denominator into just a plain old regular 2. The numerator becomes 30 root 2. And not only do I want to get the radical out of the denominator, I also want to simplify the fraction completely. So the numerator has a 30, the denominator has a 2. Those are both even numbers. So if I divide them both by 2, I would get that y equals 15 root 2. Y is one of the legs. The other leg is also x. X equals 15 root 2 as well. So there's our answer for x and y. Next one, number 4. Like the problem we just did, we're given the hypotenuse. This time the hypotenuse is 14. And we're going to go from hypotenuse to leg in the 45, 45, 90. So you're going to take the 14, divide it by root 2, rationalize it by multiplying numerator and denominator both by root 2. So we get a numerator of 14 root 2. The denominator, root 2 times root 2, is just a plain old 2. Those will simplify with each other, giving us that y equals 7 root 2 and x also equals 7 root 2. In this example, we have another 45, 45, 90. 14 root 6 is the hypotenuse, and we want to get to the legs. Because we're going from hypotenuse to the leg, we're getting smaller. We're taking that hypotenuse, dividing it by our ratio of root 2, and then as we simplify this one, I can divide the numerator by square root of 2, divide the denominator by square root of 2 to get my answer for x, which is just 14 root 3. In the next example, we have the same scenario. We have the hypotenuse, and we want to get to the leg. So we're going to take this 8 root 5 and divide it by root 2 to get y. So y is 8 root 5 over root 2. Now, unlike the previous one, this time those two square roots aren't both even. They can't simplify with each other. So we're going to have to rationalize the denominator, multiply by root 2 and root 2. So then the denominator is root 2 times root 2, which is just a plain old 2, no more radical down there anymore. Your numerator is 8 times root 5 times root 2. That comes out to 8 root 10. So that looks better right now, better than what we had before. There's no more radicals in the denominator. Root 10, if you try to break it down, would be a dead end. There's no way to simplify that. However, I can divide this by 2 and divide that by 2 to get a simpler answer for y, which would be 4 root 10. So y is equal to 4 root 10. We'll do one more in this section. Let's draw another 45, 45, 90 triangle. And we're going to make this length equal to 8 root 6. And now we're trying to find w, which is the hypotenuse. 45, 45, 90, a leg of 8 root 6. We want to figure out what is the hypotenuse w. The question as always is, what does the 8 root 6 stand for? And then what are we going to do with it? Well, it is one of the legs. We're trying to get to hypotenuse, so we're going to get bigger. We're going to multiply that by root 2. So take 8 root 6, multiply it by root 2, and that will give us w. That would come out to 8 square root of 12, which is an answer, but it's not the answer because it's not completely simplified. I don't have to worry about fractions this time. There is no denominator. However, root 12 will simplify down, so branch that down, figure out how would you simplify the square root of 12. Well, I know that 4 times 3 is equal to 12. The square root of 4 is 2 times root 3, and then bring down that 8 from out front. So then this w value isn't going to be written as 8 square root of 12. Instead, we're going to say that that value is 8 times 2, 16 square root of 3. There is our value for W.